Okay, so good afternoon from me as well. Thanks for coming to this class. I'm Alessandro Gasso. I work in Autodesk Product Support since 13 years, 13 years, supporting mainly Inventor. I'm one of the co-author of the Inventor Being Inventive blog. There are more to there. How many of you knows the Being Inventive blog? Okay, I hope you can find it useful. I presented other classes in the past AU about Content Center Library and Drawing Manager. Has any of you attended one of my previous classes? No? Good. Okay. So basically, working in product support, in my classes, I try to collect possible solution to the common question we receive, but as well to solution to some, what we find unusual questions. So basically, I'm going to do the same with this class. So I'm going to present 9 topics. You can see just 4 of them because there were just 4 bullets available on this slide, but of course we are going to see all of them in details. The class target, I think, is for beginners, intermediate. By the way, I'm going to use the PowerPoint as less as possible. I will live demo all the topics, so I think even if you are a very beginning Inventor user, you should be able to follow. Of course, if there are advanced Inventor user, I hope you can find something useful in this class. Okay, I've been asked to ask you to leave the question at the end because this class will be live streamed. And so I hope we will have enough time at the end. In case, please come to the microphone for asking your question. Otherwise, I will be available with my colleagues also after the class if you have a question. So let's start because 9 topics in less 60 minutes is quite ambitious. So the first topic I want to present is how to add part to top-down assembly. So basically, let's see what I mean with that. Okay, we are talking about multi-body parts, okay? And from a multi-body part, so this is a part that contains 4 bodies, I can create an assembly from Manage tab, Make Components. I can select a few of those bodies, and then I can create an assembly where each component basically is a derived component of the multi-body part. The components are, of course, in the position where the bodies were in the part, but of course I can, in the assembly, I can unground the component. I can apply different constraints or make other modifications. So let's assume I have created already a couple of assemblies from these multi-body parts. So this one and this one. And then I realize that I have forgotten to select one of the bodies, or I have not selected for some reason, or I have created afterward. Now I want to insert the additional solid as an additional component in one of the existing assembly. So how can I do that? Once again, Make Component. I select the additional bodies. And one way is, for instance, if the target assembly is under this folder, I can just type the name of the existing assembly, and I will get the additional body here. So even in this case, I can move them, apply constraints. Then let's create an additional solid body. So very easy one. I create another body. And now I want to insert this additional body in the other assembly. So once again, I go here. But in this case, this assembly is not under this folder. Is nested under another folder. But even if it was under this folder and I don't want to type the name for avoiding typos, or I just need to click here. And then in this message, I click no, because I don't want to create a new target, but I want to select an existing one. And then I select the body, the existing assembly. I need to select, of course, also the body. And then I got the body in the other assembly. Okay, so this was the first topic. I hope it was interesting. So the second one, I want to create, so the first one was for part assembly. This one is very specific to the part environment. So I want to create a chamfer on a corner point. And I'm going to show you two ways for doing that. The first method, with the first method, we create a chamfer with equal x, y, and z dimensions. With the second method, we create independent x, y, z dimension. So let's see how we can do that. Okay. So this is a simple box. So for creating the chamfer, surprise, surprise, I use the chamfer feature with the option distance. I select the three edges that create basically the corner. I make sure that the setback is enabled, and I create my chamfer. Then with the direct functionality, but the delete option, I remove those three faces. Okay, and then I get my chamfer on the corner point. And of course, if I edit now the chamfer, I expect that it updates as I want. Okay. This, I would say, is an easy one. Let's see if instead I want to create independent dimension for the three directions. So for doing that, I create a 3D sketch. Then I include the three edges. Then I add the point, one point on each edge. And then I apply dimension. So for instance, this will be x 15. This will be y 7. And this will be z 20. Okay. Then I create a work plane through those 3 points. And then, for instance, with a sculpt feature, I can cut out the corner. And then, of course, I can edit the 3 dimension. You see? And I get the update also in real time. And I get this feature with 3 independent dimensions. Okay. And this was the second topic for the part environment. Now let's move to the third topic, that is for sheet metal view, flat pattern sheet metal view. So basically, I want to show the direction of the bend for a sheet metal part based on line color. So for instance, up I want red, down I want blue. How can I do that? for doing that, in my drawing, I go in the style, and then I select the layer for the bend center line. And I want to use this layer for the up direction. So I said, okay, plus, and then I say, okay, I want this red. Then selecting this layer, I create a copy of it, and I want to use the copy for the down direction. So this is minus, and then down, so blue, I'm down, blue. So I save this, and then I go in the object default, and for the sheet metal bend center line up, I have already the layer set, and I change for the down, selecting the minus bend center line. So I save. Of course, everything that I do in the style can be saved in the style library, in the template. So now I create the view of a flat pattern, very known sheet metal part, this one. And I can see that I have the colors. So let's verify that the colors are correct. So applying a node. So this is up, this is down. But let's verify also that in case I edit the flat pattern definition, for instance, changing the base, flipping the base face, my annotation will follow. Okay. And this was the third topic. Okay. The next topic is something that I would define as an unusual question, as I was saying at the beginning. By the way, we have received this question, so probably for some of you could not be that unusual. So, in my drawing, I set my dimension style in the way that I want to use alternate units, for instance, in this format, and also tolerance. So, something like that, for instance. Okay. So, now I create the view of a simple part. And of course, applying my dimension, I will get this annotation. Now the question is, can I just display the tolerance for the primary unit and not for the alternate unit? And the answer is no. So there is no setting for that. But I'm going to show you a workaround that can work for small tolerances, so I hope it can be useful in some way. So the workaround basically is this one. So here, as you can see, there is no option to say, okay, I don't want to show the alternate units tolerances, but I can set the precision, okay, for the alternate units, for instance, to 0, but this is not enough yet. I need to change as well this display option. So I need to use this one, suppress display. And in this way, the tolerance does not show up. By the way, this is a workaround. So as all the workaround, there are limitations. The first one, as you can see, the brackets does not move close to the last digit. The other limitation, if you use inches as alternate units, is that this is working just with the decimal format. If you use another format, it's not going to work. And as I said, the other limitation is that since the key, basically the key step here is to set the precision to 0, as you can imagine, this is going to work just for small tolerances. So if my tolerance is this, it's still working. But if you make the conversion from millimeter to inch, of course, this will be rounded up to 1. By the way, I hope that if you need to do that, yes, this small trick can be useful. Okay, the next topic, basically, I'm going to show how you can insert inventor drawing views in the model space of a DWG as blocks and with the right scale. So let's see how we can do that. So the key point for doing this is to use an inventor DWG. I've set this as my default. So in case you have the IDW as your default, you need to select it from here, the DWG. And then I create the view of a simple sheet metal part, flat pattern. Okay. Now, in an inventor DWG, at this point I can right-click one of the view and say Insert in Model Space. And if I do that, I get my view in the DWG model space, and I get also a block corresponding to this view under the drawing resources. By the way, this works just with one view, because if I try to do the same with a second view, the option is grayed out, as you can see. By the way, this is not a problem, because at this point, I just need to save this file, and as you can see, I will get also the blocks corresponding to the other views. So at this point, if I open my DWG in AutoCAD, so this is the layout, but if I go in the model space, I can already find the view that I have inserted from Inventor. And then I go here, Insert, and I can insert also the other, the blocks corresponding to the other view. So this is the view number 2, and I can easily alienate it using the AutoCAD snap. And then, if I want, I can add annotation and other stuff. Okay. And of course, this will be linked to the inventor model, because of course, if so now we are back in Inventor, but if I make a change in the model, so for instance, I unsuppress this feature, of course I will get the update also in the AutoCAD model space, as you can see the old. Okay, so let's move then to the next topic. Okay, now, so we have seen some topics related to the drawing manager, also this last one related to the data exchange. And Okay, now we are going to see a series of topics related mainly to the Content Center library. So the first one, I'm going to show how to use, let's say, a tube and pipe fitting in an assembly as a normal part. So I open from the Content Center an elbow, tube and pipe elbow, with the option as custom. And I'm going to save this part in the some location of my machine. Then I can make modification to this part. For instance, I can create an iMate with this part. Okay. Now I open a simple assembly. But for instance, in one of the parts of this assembly contain an iMate that is compatible with the one that I have applied to the fitting. But if I try to insert the fitting in this assembly using the iMate, this is not going to work. I get the tooltip that asks me to select a run, but I don't have a run. If I right-click, I get the typical tube and pipe context menu. If I place the part in the assembly, in the browser, I get the Content Center icon. If I try to demote the component, I cannot do that. If I try to replace it with the normal part, I get an error. And all this is due to the fact that even if I have saved this part with the option as custom, the fitting still contains the authoring information that allow us to use it in the tube and pipe environment. So if I want to use it as a normal part, I need to remove this information. And in the material, in the class material, you have two scripts that you can use for this topic. So the first one will just remove the authoring information from the fitting. So I just need to go in the VBA editor and select the document corresponding to the fitting. And I just have to pass the script and run it. After that, if I try to insert again using the iMate the fitting, now the iMate is going to work. I get the context menu as for any other part. So for instance, I can place and ground it to the origin. As you can see, the icon is the icon of a normal part. If I want, I can demote the fitting. I can also replace it with a cube, a normal part, with no problem. By the way, if you right-click on the part in the browser, there are those two options that tell me that there are still some Content Center properties in the part. This should not harm, but if you want to get rid of all the Content Center property of this part, you can use the second script that you have in the material, that you can easily combine with the first one. So just and after you run it, you just go back in the assembly, and the two options coming from the Content Center are gone. So from this moment, this is a normal part, 100% normal part. Okay, so let's move to the next topic. Okay, preliminary remark for the next two topics. If you want to follow the same steps, in your project you need to have a read and write library. So in this case, I'm just using the standard my library read and write. And the first topic that we are going to see is how we want to calculate the cost, for instance, of a structural shape component that we are going to use, for instance, using frame generator, based on a standard cost per meter length. Because we want to use this value, for instance, in the bill of material and parts list. So how can we do that? So the key step here is to copy the family of the structural shape in my read and write library. So let's copy, for instance, this family. Okay. Then I insert from the content center any member of this family with the option as custom, that is the default option for the steel shape component. And I save it in some place on my machine. Then I create two numeric parameters. So the first one is cost, let's say, per meter. If you want to make cost per inch, the procedure basically is the same. You just need to apply small changes. Okay, as you know, we don't have the currency here, so we select unitless. And then how much it costs this component. Let's say $15. Don't know if it's cheap, it's expensive. Anyway, $15. And then we create another parameter. This is the cost parameter, unitless as well. And in this case, we need to create an equation using the GL parameter, that is the length, divided by 1 meter, and multiplied for cost per meter. Okay. Okay. Then we select also the export checkbox, because we want to change a bit the format of this parameter. For instance, I want to display the unit string and the trailing zeros, for instance. Okay, so I save it, and then I go in the content in the editor. I select the family. I need to select the read and write library for doing this. Otherwise, the option that I need to use, replace family template, will not be available. So I replace the family template with basically this component that I've modified. Come on, okay. And once I do that, for instance, I can use this family with frame generator and doing something like that. Okay. So I select the family that I have modified. I can select any member. Of course, I don't need to select the one that I've modified. And then I create my frame assembly. And I can already see the parameter that I have. I can already recall the parameter that I have created in the bill of material. Simply doing that. And you see, this is the cost per meter, so it's related to the unit quantity. By the way, if I create a view of these, and then I insert the part list. In the part list, I have much more options. So for instance, let's see all the things we can do with the part list. So first of all, we recall also in the part list the cost parameter, but we want to create as well another parameter, total cost, and we can apply also the currency already here. Then I can add the unit quantity, and I'm going to, for instance, to move up the total cost near the quantity, and okay. Then for the cost, I can just, if I want, I can just add the currency here. Since we are talking about meter, for the quantity, I can display the length in meter. Okay, and I do the same with the quantity here. So meter. And with the total cost, I can do something like that. I do a substitution. I select the cost, and I select here the sum of value. And here I have the quantity with the total cost, the unit quantity with the cost per meter, and I can also for instance, group the C shapes, for instance, using the stock number, and I will have also the sum of the quantity with the total cost. Okay, so I hope it was interesting. And let's move to the next topic. So I want to change the BOM structure of a standard part family. So let's see what I mean with that. So simple assembly, very simple assembly. I insert the component of a family from the content center library. So for instance, this family. Couple of components. And if I look at the bill of material, by default, all the content center family, they have the BOM structure set to purchased. Okay, let's assume that I want to change the BOM structure of this family from purchased to phantom, because I don't want to display the component of this family in the bill of material. And okay, in the part list, actually, you have an option for doing that, even without changing the family structure. So just to be complete, you have the filter that with the standard part, so you can use either the purchased item or the standard content. By the way, basically the purpose of this demo is just to show how you can change the BOM structure of a content center family. The purpose could be also a different one. So I'm not going to use the filter in the part list. So for changing the BOM structure, once again, I need to copy the family in the read and write library. Then I insert one member of this family with the option as custom. And I have just to do that in the document and setting. I change the BOM structure from purchase to phantom. I save this file. I go back to in the editor. I set the read and write library here, and I replace the family template using the file that I've modified. So once I do that, in an existing assembly that contain already those components, I just need to make a refresh. Inventor tells me that they are out of date because I've changed the bump structure for this family. So I make a refresh. And now if I open the bill of material, the standard components are not there anymore. And of course, in the drawing as well, without using filters. And of course, if I insert any other member of this family, it won't display in the bill of material and in the part list as well. So this is the procedure if you need to change for some reason, the bump structure. Okay, let's move to the next topic, that is also the last one, and then you will have time for question. Okay, manage the content center file when you move to a newer Inventor release. Okay, for showing you this, I need to use an older version. I have a couple of this installed on this machine, so I'm going to use Inventor 2014. So when we install Inventor with the default setting, as you know, in the application option, so in the application option, File tab, the path to the Content Center file folder, so the folder under where Inventor creates the file when you use the standard part from the Content Center, is under a folder that basically has the name of the release, so in this case 2014, and is also related to the user profile. So if in your project, under the folder option, you have the Content Center file set to default, basically Inventor will create the file for the Content Center under this folder. So if I create an assembly and I use and I insert some standard part in my assembly. Any part, just for demo purpose. So I save my assembly. Now I upgrade to 2015. And okay, come on. And I install Inventor 2015 with the default setting as well. So also in this case, in the application option, File tab, I have basically the default path to the Content Center file folder is related to the version. So in this case, 2015. So what happens if I use a legacy project? So a project that I was using in Inventor 2014, that was this one. That, as you remember, where the Content Center file was set to default. It's always default, but in this case, since I have moved to 2015, the folder is not the same. So now if I open the assembly, I will get a resolve link dialog. Okay. How can I do for avoiding this now and possibly forever? So I need to change the path here and select a path that is not related to the release version and possibly also not to the user. So in this case, I will use this one, but you can use any location. So this, I will set the path to this location. Then so this is the new location. And this is the location where Inventor were storing the content center file by default. So I will take this folder that contains all the families with the component from the older release, and I copy this folder in the new location. Then, of course, if I have used Inventor 2015 also with new project, not just with legacy project, probably under the 2015 folder, I have other family folders. So, of course, I want to move also those folders to the new location. So I copy the folder under the ENUS folder from the latest version, and I copy under this folder in the generic new location. If I get those dialog, I need to say yes and copy and replace, because so I will get the newer file. And once I do that, and I come back to Inventor, so if I reuse the legacy project, here the option is still default, but now the default, is unrelated to the version number. So now if I open my assembly, Inventor will resolve the link with the content center. And when you will move, you will upgrade to the next version, the only things you have to do, or you have to check for avoiding this problem, you must go here, application option, file, and set the default content center file path that point to the generic location where you have stored the content center file from all the version. Okay, so this was the last topic. Oh, just a couple of clarification about this last topic. I've mentioned this folder ENUS. If you use the content center in another language that is not English, of course the folder is this for German, this for French, this for Italian, and so on. And another thing to mention, of course, if you were using custom content in previous version, you need to migrate them. This is in the documentation. You have the link that point to the help file that explains how to do that. And if you are moving from release 2012 or previous version to the latest version, it's recommended that you make a refresh of the content so that you have the content that are up to date. You can do this in batch mode using task scheduler, or on the fly, enabling this option in application option, content center tab, refresh out-of-date standard part during placement. So now we have some time for question. If you have any question, please come to the microphone, and I will try to answer if I can. Okay.
I'm using AutoCAD 2013 and Inventor 2015, and I want to move blocks. I can still do this?
Yes.
And
yes.
it'll still work?
Yes, okay. Because basically what you need is an inventor DWG. The inventor DWG, if I remember correctly, has been introduced in Inventor 28.
Okay.
So, and you can also use, if you are an AutoCAD user, you can use the insert or also the design center. From the design center, you can insert the block, alienate, and everything. Yeah. No problem. Any other question? While you, don't be shy, while you are thinking, I would like to remind you to fill up the survey, possibly following the indication of the slide for the, no, just kidding. You can get a free pass for the next AU, and also, I mean, if you have attended the keynote from Carl this morning, you are already aware of this, in case you are a student and if you need the certification. No other question? So, I give you back 10 minutes then. Thank you for coming and attending, and thanks a lot. Thank you.